All right, these are problems 6 through 9 on review day number 6. Number 6 gives us a graph of a function and asks us for the derivative. So it's a product rule. It's going to be derivative of the first times second as is, plus first times derivative of the second, which is just e to the x, and then this goes away. We don't see that as an option, so distributing this would be our next best bet. 2x e to the x minus 2x plus x squared e to the x. And then we can kind of hunt for that one, and that shows up right there at C. All right, so not too bad. Little product rule with a little simplifying. Okay. Number 7 here says a particle moves along the x-axis. Its acceleration is this. The velocity at 0 is 7. Position at 0 is 0. What is the position function? So in other words, we have to integrate a couple times with plus c and kind of find that as we go. So we'll integrate first to get to velocity, and the integral of sine is negative cosine. So this is going to go to a negative or a positive 4 cosine 2t. But then the problem here is that if I were to take the derivative of this, the derivative of cosine would be negative. That'll give us the negative part, but then a 2 is going to pop out here, right? And we don't want that 2 in the end. We want it just to be 4. So I don't want the 4 here. I really want that as a 2, right? And then plus c. So you can do that as a u sub, or you can kind of do that on, in your head. What would I have to have here so that when I take the derivative of that, it gets me back to here? Now I want to plug 7 in for the velocity and 0 in for my time. So it'll be 2 times the cosine of 0, which is 1. So just 2 there plus c. So that gives me a c value of 5. Okay, so my velocity function then is 2 cosine 2t plus 5. All right, now I want to get to the position function. So the position function is the integral of this. So the integral of cosine is sine. And again, when I do the derivative of this, a 2 is going to pop out. That's that 2 right there. So I don't want anything in front of here right now. This derivative will get me right back to here. That's what I want. Okay. And then the integral of 5 is 5t. So I end up with sine 2t plus 5. The initial value, well, plus 0, c. But if I put 0 in, sine 0 is 0. This zeroes out, so I do get c equal to 0, and it leaves me with sine 2t plus 5t, which was letter A. Number 8 gave us a graph. It tells us that this is f double prime, the second derivative, and it says if that's the second derivative, then which of the following could be a graph of the actual f? So this isn't telling us about concavity. When it's positive, f is concave up. And when it's negative, f is concave down. So we're looking for a function. Which one of these down here is concave up until here, concave down here, and then concave up again? So I'm looking at my options, and I see that this is concave down for this whole spot here. It's supposed to be concave up. That part, that's not going to work. All right. This one's concave up until 0, and then it's concave down afterwards. I don't want that. I want it concave up twice, down in the middle, so that's out. Okay. This one is concave down until here, and then concave up in the middle, and then concave down. And I want something like that. It's just the opposite, right? It's not that. I want this one right here. This is concave up until about here, then concave down, and then goes back to concave up. So that matches the second derivative graph there. And then our last one here tells us that when x is 2e, what's the limit of this? So again, we want to recognize this as a derivative idea. This is the derivative of natural log, which we know is 1 over x. All right, and then when x is 2e, what would that be? We'll just throw 2e in there, and we get 1 over 2e. It's actually a pretty simple problem if you recognize what that is representing. If you do a L'Hopital's, you can get there too, but it really is hinging on, do you recognize this as the derivative of natural log, and then just throw 2e into it.